Hey Algebra, last lecture in chapter 6, this is the product of special binomials or special products of binomials. And this is one that is really just fun because if you practice this enough, you begin to see patterns, and I'm trying to help prevent you from beating yourself to death by doing practice and not seeing the pattern. What the heck am I talking about? Let me show you. Again, please follow along in your book. Pause as you go. Now, if you want, pause this video and try these 6 problems. Welcome back. When you square each one of these monomials or binomials, a squared, of course, is a squared. 5a squared is 25a squared. 3 plus 4 squared, and you're like, wait a minute, can't I just combine 3 plus 4 and then square it? I hope that's what you did. 3 plus 4 is 7 squared is 49. A plus b squared, well, now you're thinking FOIL, right? You should end up with a squared plus 2ab plus b squared. Well, what about x plus 1? You should have gotten x squared plus 2x plus 1. What about, oh my gosh, 2x plus 3? Well, that's just 4x squared plus 12 plus 9. Now, I did these pretty fast, and then you're going to say, well, of course you did. You already had the answers already worked out. But there's a little shortcut, and that's what I want to show you. Imagine a square with the sides of a plus b. So here's a and here's b, and you're adding them together to figure out the area of all of it. What you're really doing is you're saying, well, the a times a is a squared, and a times b is ab, and b times a is ab, and b times b is b squared. And you're going to combine all 4 of these, right? Well, there's a little shortcut that goes with it. You've got the first term squared, a squared. You get the last term squared, b squared, and you have 2 ab's, combinations of the 2. Well, actually, that's the shortcut. That means a plus b squared is really a squared plus 2ab plus b squared. This is called a perfect square trinomial. And the reason you want to see this now is we're going to, in the next chapter, back these things out. We're going to work backwards to figure these things out. So where I'm going with this is, notice the FOIL pattern always leads to the same result. The first term squared, 2 of the first and the last term combined together, and then the second term squared. Every time you have a binomial squared, a binomial added together, it's going to follow this pattern, a squared plus 2ab plus b, where the first term is a and the second term is b. So check this out. What this really means is x squared plus 2 times x times 3, x being a, 3 being b, and then b squared, 3 squared. Holy moly. That is way quicker if you can see the pattern, right? 2 times 3 is 6 times x is 6x. 3 squared is 9. Again, in this example, the first term, a, is 4s. The second term, b, is 3t. So 4s squared plus 2 times 4s times 3t plus 3t squared gives you 16s squared plus 24st plus 9t squared. Please pause the video. Get this in your notes. These are really good examples for what we're trying to do. Okay. Oh, I forgot to hide these. Oh, well, bummer. What about these? You'll notice these is a binomial, really, that's being subtracted. And so 3 minus 1, of course, you say, well, that's just 2 squared. Well, x minus 1 squared ends up with x squared minus 2x plus 1. And a minus b squared is a squared minus 2ab plus b squared. Well, wait a minute. That's a very similar pattern. The difference now is you're subtracting the middle term. And again, a negative times a negative is always going to be a positive, but you're going to end up with a negative middle when you have the difference of squares, right? So check this out. Again, I'm just going to do the example a and b. The a term is the x, the b term is the 6. And again, I'm subtracting them. So I end up with x squared minus 2x, 2 times x times 6 plus x squared. And you simplify that out and you get the negative 12x in the middle. This other example here, the a term is 7. I'm subtracting it with a b term of r to the third. Don't freak out. Love it. Set it up. First term, a squared, 7 squared, minus 2 times 7 times r cubed plus r cubed squared. Now you might get a little messed up with your how to carry this out, but really that's just 49 minus 14r cubed, and r cubed squared is r to the 6th. Now, the last example here, you're going to notice is called a difference of two squares. And I'm sorry if I used that term earlier, but what I really mean is I've got a binomial with addition, and I've got the same values, but now subtracted. And when I multiply them together, 5 plus 2 is 7, 5 minus 2 is 3. You multiply those together, you get 21. Okay? This one, you just get a squared minus b squared. And again, if you pause the video, actually, if you haven't already done it, pause the video and do these last two. If you FOIL them out, you should get the results, x squared minus 1, and down here, 4x squared minus 9. Notice in these examples, there's no middle term. Huh, interesting. Well, really what's happening here is you're saying, I've got a squared, and I'm going to take this little portion out of it, right? So I'm going to take a plus b, right, and multiply it by a minus b. Well, really what I'm ended up doing is I'm removing this part. And you can see how they've taken this little bit down here, and they said, okay, here's a plus b. I'm going to take this little bit and slide it up here. Now I've got a plus b over here and a minus b over there, and you'll notice you've got a little piece missing, and that's called the difference of squares. So again, now when you see this pattern, you notice you're not actually squaring the same thing. You've got the sum and the difference. You can use this shortcut. Well, the first term is x, the second term is 4, so it's going to be x squared minus 16. And here the first term is p squared and the second term is 8q. Well, set it up. P squared squared and minus 8q squared. You get p to the 4th minus 64q squared. This one here, the a term is 10, the b term is b. 10 times 10 is 100, and minus b squared. That's really all of it, okay? So again, when you've got these examples, you can start seeing things like, oh, wait a minute, I've got one thing here, I've got a difference there. I'm not going to go into this example right now, but write a polynomial that represents the area of the yard around the pool. Really what I'm doing is I'm going to subtract this piece from the bigger piece, right? So this is the difference of squares. So it'd be like x squared minus 4 is the area of that. This one here would be x squared plus 2 times x times 5, 10x plus 25. And I could actually subtract those and I could do the math and figure it all out. What I hope you've done in this lesson, and I'm just over 8 minutes, is you've written down these rules. The first one are perfect square trinomials. In the first case, where the terms are being added together. The second is where they're being subtracted. And then the last one is the difference of two squares. So it's not exactly the same, but they have the same terms. One's addition and one's subtraction. Again, we're going to practice this in class. We're going to work together. And you really need to know these rules because starting next chapter, you're going to see trinomials and you're going to try to back out what was multiplied together to get you there in the first place so you can solve real life problems.